System, then we came to the different types of ecosystems. Then we talked about the transition ecosystem, which is otherwise called as ecotone. This is what we discussed in the previous class, right? Now, before going to enter the ecotone and ecocline and various other issues, our friend Mr. Pratik is having a question. Like, see the question. Aquaphonics can be categorized under which kind of interaction? Can it be considered under commensalism? Now, let us see the two terms that are there right now. One is called as commensalism. Another one is called as aquaphonics. These are the two terms which are being given by Mr. Pratik, and he wants to compare whether it is commensalism type of thing, or the aquaphonics it is commensalism or some other thing. First of all, what do you mean by commensalism? Commensalism is a type of interaction where you can find the two species which are biologically interacting. One will be positively benefited, another one is inhibited. Means what? Another one is not inhibited, it is neutral. One species get benefits, another species is neutral. This is what called as commensalism. Now, coming to this one, what is called as aquaphonics. What is this aquaphonics? There are certain terms like, let us see certain things like aquaphonics and hydroponics. There are two things like aquaphonics and hydroponics. What do you mean by hydroponic and what do you mean by aquaphonic? After discussing this one, then we will compare with the commensalism. Commensalism or some other ism. Let us see this one. What is aquaphonics? Hydroponics. In fact, aquaphonics derived from hydroponics. What do you mean by hydroponics? Cultivating the crops without the help of soil. Soil will not be there. There won't be any soil. Without soil, cultivation. How come there can be cultivation without soil? This is called as hydroponics. What is the concept? See this one, this is a small pipe-like structure. It will be like this, and it will be having all sorts of perforations. In this one, where the plant sapling will be kept. This is a plant sapling. The plant sapling will be kept. Under this one, you can find what is called as coir, coconut coir. Coconut coir plus nutrients will be mixed and the plant will be grown here like this. And into this one, through the pipelines, water will be pumped here. This is a big tank that will be kept here. The water will be pumped here, and the water will be, again it will be collected here like this. The water will be coming here, the water will be pumped into this one. This is what the mechanism. Continuously the water will be flowing. The water will be flowing continuously, circulating. Because of the circulation, what happens here, you can add some of the nutrients like nitrogen, phosphorus, potash. Those will be keep on circulating. Whenever they are keep on circulating, what happens, you can find the growth of the vegetable, leafy vegetables and some other vegetables like maybe tomatoes. These products will get cultivated here in this mechanism. This is what called as hydroponics. With the help of the water, without having soil, where the vegetables can be grown. This is what the concept of hydroponics. Right? Now, what is happening? The water is being circulated. In this one, what is a very important benefit is, in the traditional mode, whenever you are consuming 100 liters of water, in the hydroponics you will be utilizing only 5 liters of water. Just imagine, where are 100 liters of water, 5 liters of water. This is the concept of hydroponics right now, where the entire urban folk are growing vegetables on this method. Right? Even there are certain training sessions are there. You can enroll the training session in the terraces of your balcony or somewhere. You can grow this one. This is a simple mechanism. Now coming to aquaphonics. What do you mean by aquaphonics? Releasing of fishes here. releasing of fishes here like this. If at all you are releasing fishes in this one, the fishes will be grown here. Whatever the waste released by the fish, whatever the waste released by the fish is being consumed by the plants, whatever the waste released by the plants will be consumed by the fishes. What is happening here? Both the products are mutually benefited. Like whatever the waste that is released by the fish waste, like excreta of the fish, is being consumed by the plants as a nutrients. Who is benefited? Plants are benefited. And the waste of the plants will be released into this water, and the water will be coming and it will be dropping here. The waste will be consumed by the fishes. What type of relation is this one? Can we call this one as commensalism or some other thing? See, this is what the concept. If you are clear with the concept, you can apply the concept anywhere. Hope Pratik got the answer. Is it okay, Mr. Pratik? This is what the aquaphonics and the commensalism. What will be taught here, what will be given in the material, all the individual concepts will be given. It is you need to interconnect. Is it clear? What is the waste of the plant that is released? What is the waste of the plant? The plant waste are in the secretions, where they will be utilized as a food material for the fishes. Yes, it is what is happening. Therefore, both they are mutually benefited. Clear? This is how we can explain. Fine? Is it okay? This is about the aquaphonics, hydroponics, commensalism. This is the dependence, which is otherwise called as interrelation, biological interrelation. Right? Now, after the doubts, let us enter into the regular class. Give the heading as types of ecosystems. Already we have seen the different types of ecosystems. Like there are two types, terrestrial, another one is called as aquatic. Terrestrial, otherwise another one called as aquatic. In between these two, there is a transition ecosystem. We have explained, we have dictated what are the different types of ecosystems that are there on the land, what are the different types of ecosystems that are present in the body, in the water body, whether it is the saline water body or the fresh water body. After discussing all these things, now we are coming to such a very important concept, which is called as the transition between the land and the water, which is called as the transition ecosystem. Such a transition ecosystem is technically called as ecotone. This is what? The ecotone. This is the ecotone. What is ecotone? This is the water body. Whenever a river is coming and draining, into the sea or ocean, where it can be what is called as delta or estuary. It can be delta or estuary. Now I got it out. What do you mean by delta and what is estuary? What is the difference? Come on, what is the difference between the delta and estuary? Explain, come on. You should be very, very careful regarding the terms. Whenever you are using the terms like estuary, like delta, you should be very careful. What I said just now is the point where the river is draining into the sea or ocean. What is the point where the river is draining into the sea or ocean is called as delta, either delta or estuary. Why it should be having two terms? What is delta? What is estuary? Come on. I want clarity. Come on. What is the difference between the delta and estuary? In this area, you can find a unique type of waters where their waters are called as brackish waters. Brackish waters. Delta carried more sediments. Estuaries carries less sediments. Abhishek Kumar Pandey. Is it the difference? Come on, I want answers from everyone. Though you may be wrong, I don't bother, but giving answer is important. Come on. Delta is depositional landform. Estuary is mixing of water. Difference in the sediment material. Oh my goodness. Difference in the sediment material. No. Whatever the answers you have given, they are not absolutely perfect. It is absolutely correct. Delta is deposition landform. Estuary is mixing of water. No. Sediment in delta and low flow of water. No sediments and high flow of water. Estuary. Sedimentation in delta is taking place and low flow of water. Low flow of water, no sediments and high flow of water, estuary. To certain extent good. Jaidev to certain extent. Delta is formed when the west flowing rivers, delta distributaries, fertile estuaries, come on. Delta is formed. Delta is with the deposition of sediments at drainage end of the water body and estuary deposition of the land surface of the mouth. Delta is a place where there is a big deposition of sediments and estuary where the mixing of the water. Now see the point. See here, very very important, because these are the small terms, though they are very very small terms, you should be having a good understanding. See the point here. All the people are giving the number of answers, like Rahul Srivastava has given. Estuary is an area where the salt water mixes with the fresh water. It is a form of alluvial deposit. The river divides entering into the water body. Deltas are depositional wetlands becoming a mixing of water. Estuary. Pratik. Listen this one. Why all deltas are located only in the western continent? Means what? Western coast of India. You take any delta, Sundarbans delta, Mahanadi delta, Krishna Godavari delta, Kaveri delta, Vagai delta, all they are deltas. Whereas in the western coast of India, Narmada estuary, Tapti estuary, Mandovi estuary, Zuari estuary, then Idukki estuary, Pamban estuary, Periyar estuary, Neyyar estuary, all they are estuaries in the western coast of India. Why deltas are present in the east coast? Why delta estuaries are there in the western coast? See this one. What is the difference? You have given some of the answer before entering into the sea. The river is divided by low, shallow of these lands are called as deltas. Now listen, very good. Some of the people are having some clarity, but most of the people, whatever the difference you are talking, they are not up to the mark. Come on, let us see this one. Though it is not up to the mark, it doesn't mean that you are not good, like, right? It is a process of where you can learn these things, right? Come on, understand this one. What is a delta? What is a city? Suppose if the coastline, in the delta region, what happens as the coastline is having very less slope? When the slope is very less, the river remains almost all stagnant. When the river remains almost all stagnant, the deposition takes place on the land itself. On the land itself, therefore you can find the deposition of the sediments over the land, and the river mouth becomes larger in size. Such size, this is the one. See this one, the river mouth becomes larger in size. That is what called as delta. This is delta. There are different types of deltas, like bird food delta, like what is the other one called as cuspate delta. There are different types of deltas like bird food delta, arcuate delta, cuspate delta. There you might have come across in geography. Okay, I don't want to enter into geography. Come on, but whereas estuary, understand this one. Whenever the coastline, this is the water, ocean or sea. Pay attention. This is a land. This is the ocean or sea. The moment when the land is flat, the slope is almost all zero, then the river remains stagnant, or the river water remains stagnant. Therefore the sedimentation takes place on the land, which creates wider mouths, which are nothing but deltas. They are triangular shape and they are called as deltas. Suppose the land which is present near the coastal area is slant, slopey, very steep. This is the sea or ocean. Then the river water will not be moving very sluggishly. The river water moves with a greater velocity. When the river water is moving with a greater velocity, the river is having enough potential to carry the sediments, and the river never opens its mouth wide. Therefore, the river has one channel, it enters and penetrates into the sea or ocean without deposition of sediments on the land. Why there is no need of deposition of sediments on the land? Because river is having enough velocity. When the enough velocity is there, enough carrying capacity, when there is enough carrying capacity, therefore the water enters gushing directly into the sea or ocean. This is what? One single channel. The river mouth with one single channel penetrating deep into the sea or ocean without any deposition on the land. This is what? Estuary, which is otherwise called as submerged mouth of the river. What is estuary? Estuaries are having submerged mouths. Submerged mouth, where the mouth of the river got submerged, it is in the ocean or the sea. Why the east coast of India is having all deltas? Why west coast of India are having all estuaries? Because east coast is a emergent coast. East coast is, not was. Even today it is emerging. East coast is a emerging coast. When it is emerging, then what happens? The slope becomes zero almost all. When the slope is zero, the river cannot move with a greater velocity and all the sediments are deposited on the land, creating a wide mouth. It is not a submerged mouth. Whereas the west coast of India is a submergentive variety. The moment when the west coast is submergentive variety, rivers can gush into the sea or ocean or Arabian Sea. And so all the rivers like Narmada, Tapi, what type of mouths are there? Submerged mouths. Therefore, what they are creating? Estuaries. Not only Narmada and Tapti, also you can find the rivers like Mandovi, Zuari of Goa. The two very mighty rivers of Goa, Mandovi and Zuari. That there again they are creating estuaries into Arabian Sea. Also, the rivers like Periyar of Kerala, Pamban, Idukki, Neyyar, all they are having estuaries. Why you can't find estuaries in the east coast? East coast is emergent coast. West coast is a submergent coast. Therefore, estuaries there, deltas here. Could understand? This is what the delta is. But understand this one. Whatever may be, it may be estuary or delta, there you can find ecotone. What type of ecotone can be there in the estuaries? Narrow ecotone. See the concept. You should be having that clarity. Why there are narrow ecotones in the estuaries? Why there is a broader ecotone in the deltas? Could understand? Now we can correlate. If you don't know what is the meaning of estuary and delta, you can't understand why they are narrow, why they are broader. Is it clear? Is it okay? See here I have given what is called as the picture of delta. Now alternatively I am drawing the delta which is called as estuary and delta. Let you compare so that you can understand what is the exact difference between the estuary and delta. See this one, if this is estuary, it will be like this. Where are we? We are there on the land, here like this. Is there any deposition here? Could able to see any channels here? There is no channel, there is no deposition. Therefore, this is what? One single channel which is penetrating deep into sea or ocean. This is what estuary is. Submerged mouth. It is having submerged. Why submerged? The river, whenever it is moving in the great slant, it will be moving with one channel and it will be pushing into the sea or ocean. This is what? The estuary. What type of ecotone you can find? See the question. The question can be asked like this. The ecotone can be wide or narrow. True or false? Which of the following statement is right? Which of the following statement is correct? The ecotones can be narrow or broader. If you don't know the narrow nature, if you know only the broad nature, you cannot explain. Could understand? This is what? The deltas, where you can find very great ecotone, entire this region, whereas here only narrow ecotone here, like this. How much it is there on the land? Only this part on the land, where that is visible for us. We can't understand the ecotone that is present in the water clearly. Is it clear? This is what is called as ecotone. Got the point? This is estuary, this is delta. Now, pay attention. After discussing the estuary and delta, ecotones are the transition ecosystems. Write down this point. Ecotones. What are ecotones? Put it the heading ecotone. Ecotone is a transition ecosystem between two contrasting ecosystems. Between two contrasting ecosystems, they can be, point number one, they can be narrow along the estuaries or they can be broader along the deltas. This point is very important. They can be narrow or they can be broader. They can be broader along the deltas, right? Now, after this point, stop, listen again. Then again we will be dictating some other points you can write. But listen first of all. See this one? This is what the ecotone. This is a transition ecosystem. What will be happening here? What will be happening here, since it is a combination of fresh waters as well as a saline water. Since these waters are the combination of fresh waters or saline water, where they are called as the brackish waters, a unique type of species can be grown here. Why unique type of species can be seen here? Because it is a combination of two characters which are of contrasting nature. What is the contrasting nature? This is the land which is having contrasting ecosystem. This is water, it is having again contrasting characters. When they are mixed here, both the characters can be seen here. Such, pay attention, very important, such observing both the characters of the two contrasting ecosystems at one point is called as edge effect. This can be again a question. See, in the preliminary part, everything can be a question. You should be having the understanding at the micro level. What is edge effect? Edge effect is such an effect where you can find the two characters which are intermixed here and they are having at the exact transition or the junction of two contrasting ecosystems. The two characters are mixed here, overlapping of the two ecosystems. This is what edge effect. Because of the edge effect, as it is having two contrasting interactions, the species that are grown are also unique. Because of the unique transition ecosystem, the unique species can be grown. Such a unique species is called as edge species. Where the species is having again unique characters which are not the characters of neither land or the what is called as the terrestrial ecosystem nor the characteristics of aquatic ecosystem. You can find both the characters. Such a species is called as edge species. Is that clear? Come on, write down edge effect. Edge effect, edge species. Edge effect, edge species. Come on, give the heading as edge effect and the edge species. What is edge effect? Edge effect, EDGE, edge effect refers to the changes in the, edge effect refers to the changes in the edge effect refers to the changes in the population, or community structures. Changes in the population or community structures that occurs at the boundary of two habitats. At the boundary of two habitats at two ecosystems. At the boundary of two habitats. At the boundary of two habitats. Full stop. the edge effect will be having a unique species with the characteristics of both the ecosystems, both the neighboring ecosystems, both the neighboring ecosystems. Such species is called as edge species. Such a species is called as edge, EDGE, edge species. Such a species is called as edge species. Stop writing. Again, listen, come on. Stop writing, listen. Listen first of all. Now see here. Okay, this is the water body. This is the area where the land is there. Now what is happening? The species are growing here. Because of the river is draining here. What the river is bringing? The river is bringing the fresh water. Along with the fresh water, what is brought? Great amounts of sediments are brought. All the sediments get deposited here like this. All the sediments will be deposited here. What do you mean by sediment? Sediment is nothing but the broken rocky material. The broken pieces of rocks. This is what the sediment, right? This is what the sediment. Maybe the sand, maybe the silt, maybe the clay, maybe the mud. All these are the sediments, right? Now, when the sediments are present here, in this one, now what happens? The plants grows. What type of plant grow? Those plants which are having elongated roots. The roots should be elongated. Why the roots should be elongated? Because the roots needs to penetrate to such a great extent so that they can firmly anchor in the sediments that are available under the water. This is the area where the transition ecosystem, which is called as brackish waters, are present. Here, the roots of the plants has to be elongated. If the roots of the plants are not elongated, there is no question of survival of the plant. The plant will get washed away somewhere. Suppose if this is a plant, if it is having not elongated root like this, can it stay firmly for a prolonged time period? No. It will be washed away, maybe because of the tides, maybe because of the waves, maybe because of the tsunami, right? But those species which can survive here they are the one which are the edge species. They will be having elongated root. It's adaptation, right? Elongated root. Why? Because they need to anchor. Not only they need to anchor into the sediments, also they need to squeeze, absorb, pull up the nutrients. What type of nutrients? The nutrients like nitrogen, potash, phosphorus, lime, all these things will be taken from the soil. Where the soil is available? The soil is available under the submerged water, submerged condition. Therefore, the roots will be present much above the water. See the roots will be present much above the water like this. You can find the roots much above the water like this. Why the roots should be much above the water? Normally what will be happening? Who will be breathing? The roots will be breathing. How the roots will be breathing? Suppose if this is the soil, when the farmer is tilling the land is made loose so that aeration takes place. What do you mean by aeration? Movement of the gases into the top layer of the soil like this. Movement of the gases into the top layer. Therefore, the roots will be having some oxygen, some nitrogen, some carbon dioxide. Therefore, the roots will be absorbing. Now here, the roots are submerged. The soil is submerged. Therefore, anaerobic conditions will be there. What do you mean by anaerobic? Where the lack of oxygen. In order to have the breath-taking facility, the roots are visible much above the water. Such a breath-taking roots, which are otherwise called as blind roots. Why? Because the roots are deeply penetrated and again they are visible to certain extent only on the surface. These are called as nematophoric roots. These are called as nematophoric roots, and the species are called as nematophores. Those species which are having the nematophoric roots, they are called as nematophores. What type of species can be grown here? Only the nematophores. What are nematophores? Those roots which are elongated, got anchored deep into the subsoil. What is the subsoil? Means what? Submerged soil under the water. And the roots are also visible much above the water. Why the roots should be visible much above the water? In order to facilitate the breathtaking facility. This is what called as nematophoric condition. These nematophoric roots, where the species are having unique characters. What type of characters? See the one. Come on, give the heading as the characteristics. The characteristics of the species. The characteristics of the species in the ecotone. Characteristics of the species in the ecotone. Come on, let us see this one. This is what? Another species. Another species. We'll be having like this. This is what the type of vegetation you can find. This type of vegetation is very, very common at the deltaic areas, wherever the fresh water is meeting with the salt water. What is this type of vegetation called as? This is called as the mangrove vegetation. Very, very important. Come on, write on. This is called as the mangrove vegetation. What do you have to write? Give the heading as the characteristics of the vegetation in the ecotone. Give the heading as the characteristics of the vegetation in the ecotone. The vegetation in the ecotone is called as mangrove vegetation. The vegetation in the ecotone is the mangrove vegetation. These are mangroves. What are these mangroves? Mangroves are, come on, write on. Mangroves are nematophoric species. They are the nematophoric species. Nematophoric spelling is there on the board. What do you mean by nematophoric? Those species which are having elongated roots and the roots are visible much above the water level. Nematophoric species are is there any streaming problem? Technical problem, is there any? No technical problem, very good. There is no technical issue as such from our end. Yet we are checking this one. Whoever is having some problem, just hold on. Okay, no such technical problem is there. Understand the concept here. Now come to this one. The type of vegetation that is present in the ecotone is a mangrove vegetation. The next point. See the next point. I have written this one, the characteristics. Now write on under the characteristics. Very good. No issues. Wonderful. Yes, sab sahi hai. No need to worry about the technicality. Now, come here. This is what don't go for breaking. Come on, let us understand this one. What type of characters they are having? One is the species are called as mangroves. They are having nematophoric roots. What are nematophoric roots? The roots which are available much above the surface. Now, could you able to see this one? One root which is taking birth here and it will be coming and again joining into the water like this. Such type of roots that takes birth from the top and they penetrate deep into the water, they are called as stilt roots. Stilt roots. The roots are stilt in nature. What do you mean by stilt in nature? The root will be taking birth from the stem and it will be going down and it will be anchoring into the soil. The side, the adjacent roots, these are called as stilt roots. From the stem, the roots will be coming like this. They will be coming like this. These are called as stilt roots. Because of this stilt root nature, what happens? The plant that is present in the adjacent side, the plant, it will be having again stilt roots. The plant is also having another stilt root like this. Because this one, this stilt and this stilt root, they get intermixed and get locked up as a chain. They get locked up as a chain. When the roots are locking up as a chain, such type of nature of the trees, what it will be doing, it will be useful for the mankind like anything. Why? Because these trees which are growing to such a tall height of minimum of 8 meters and they can be even up to a height of 20 meters. Whenever they are having a chain root system, they are anchoring to the soil with a great intensity. Whenever there is a great cyclone, whenever there is a great tsunami, the tsunami waters are having very great velocity, maybe 50 kilometers per hour or maybe 60 kilometers per hour of the speed of the water can be there for the tsunami. Even though the velocity of the sea water is around some 50 kilometers per hour, this particular rooting system of the mangroves acts as a speed breaker. They never allow the water velocity to create some fury on the land. Therefore, these mangroves are the natural speed breakers for the terrestrial ecosystems. See the importance. It was in the 2004 where the importance of the mangroves was discovered by the people. The ecologists started explaining the importance of the mangroves. Due to this one, the government of India has changed its outlook towards the mangroves and announced all the mangroves as the protected areas. Since mangroves are the natural vegetation, we can't create. If at all we want to create the mangroves, we can't create. They are but natural. Is it clear? They are but natural. Whenever they are naturally grown, what is our duty? Our duty is to protect the mangroves. What type of species? Where the name of the species? What is the name? The name of the species is called as Rhizopora. These are the Rhizoporas. The Rhizopora species which are having the chained linking characters. One is Rhizopora which is having the chain linking. Another type of species is there where you can't find such a chain linking, but they are growing elongated, but the roots are much available over the water. Where that type of species is called as Avicenna species. These are the two important varieties of species you can find here in the mangroves. One is Rhizopora, another one is Avicenna. What is the difference between the Rhizopora and Avicenna? Rhizopora roots are interlocked, chain-like structures, where they are very much useful for acting as speed breakers, not only for the tsunami, even for the cyclonic winds. Whenever the topic is cyclone, what are those winds that are associated with the cyclones? There are certain winds called as gales. There are certain cyclonic winds where the name of these winds is called as gale wind. What do you mean by gale wind? The wind velocity is more than 250 kilometers per hour. When the wind velocity is more than 250 kilometers per hour, it is having the capacity. What is having the capacity? The wind is having the capacity. The wind can bend an electric pole. An electric pole that is present there can be bended like this. This is what the capacity of these gales. Such a gale cannot do anything to the coastal area provided where the mangroves are there. They cannot uproot the trees. Very large trees like even the coconut trees, the palm trees, all they will be uprooted, but not the mangrove. See the importance of the mangroves. Ecosystem. which is ecotone, edge species. See the importance of the edge species. Can you understand the importance of the edge species? Is it clear? Is that clear regarding the edge species? The edge species are a unique type of species, very important species. Even the winds like gales cannot do anything. Fine? Now come on. What you have written? You have given the heading as the characteristics of mangroves. Come on. The first one. The first point. They are halophytes. Write down. The first and foremost point. They are halophytes. What do you mean by halophytes? They are capable, they are having the capacity to survive even in the saline water. Clear? Brackish water is also salt water. It's not as fresh, but it is salty, right? What are mangroves? Mangroves are the edge species. Number one point, they are halophytes. The second point, come on, write down. First point is they are halophytes. What do you mean by halophyte? Saline tolerant species. If at all you want, write down like this. Saline tolerant species. Fire. Then they are halophytes. The next one. See the next point. They are having thick leaves. They are having very thick leaves. Why the thick leaves are important? Because of very great pulling of the water, nutrients, some of the salts also enter into the plant system, the so-called xylem, phloem. They enter into the plant system. Because of this one, where the leaves are thick and they are having the capacity to secrete salts. They will be sending out the salts. Salt secreting glands are present. Salt secreting glands are there. What do you mean by salt secreting glands? When the salt is absorbed, because the roots are very deep, and whenever the what is called as absorption of all the nutrients are there, some of the salts are also entered. When the salts are entered, which are the not required material for the plant, therefore they will be sending up, they will be kicking out through the glands called as salt secreting glands. Because this one, the leaves are thick in nature. Now, very important point. See the very important point. What is the very important point? The third point is they are having more capacity to tolerate the sun rays. Means what? They require more solar insolation. They require, write down like require more solar radiation. They require more solar radiation. Why they require more solar radiation? In order to pull more and more nutrients on the deep inner roots, also absorb more water, need to separate the salts from the water, needs to separate salts from the nutrients. Therefore, much work needs to be done. When much work needs to be done, it requires much energy. Because of this one, they require very great amount of solar energy. And therefore, because of this one, because of this character only, where do you find mangroves? Mangroves are found. Mangroves are found because of this one. Mangroves are found only between, they are only between Tropic of Cancer and Capricorn. They are found only between the Tropic of Cancer and the Tropic of Capricorn. Means what? See the new point. Till now we feel like mangroves are present only along the coastal area. Wherever there is a confluence of fresh and the salt water, there you can find the mangroves. But is it the case even in the temperate world? Is it the case even in the polar world? No. Where do you find mangroves? Are restricted only to the latitudes between 23.5 degree northern latitude to 23.5 degree southern latitude. You can't find the mangroves beyond this latitude. Is it clear? This is again unique character. They require more solar energy. They require more solar Radiation, mangroves grows only. You can write grows only between Tropic of Capricorn and the Tropic of Cancer. You can't find the mangroves. Say for example, there is a question. Which are the following areas where you can find the mangroves? Off the coast of Florida. Second one, off the coast of Argentina, off the coast of Tasmania, off the coast of Ireland. If this is the case, without having the knowledge whether they are there or not, you can have the, if at all you are having the information, you can eliminate the other things and come to the correct answer. Clear? This is what the very important point. Then the next point, see the next very important point. They are having a unique character of what is called as viviparity. And therefore they are called as viviparian species. They are called as the viviparian species. What do you mean by viviparity and the viviparian species? Come on. What do you mean by viviparity or viviparian species? Now, whenever there is a seed, normally where the seed will be grown, whether it may be the fruit or the flower or the fruit will be releasing the seeds. The seeds fall on the soil, and on the soil the seed will be germinating. Where the seed germination takes place? On the soil. This is what the general case for all the plants, right? But these species, as such, where is the soil? The soil is in a submerged condition. Over the soil, water is there. If at all you are throwing the seed will be there in the salt water, and in the salt water the germination cannot take place. Therefore, the process of adaptation, see the nature is so beautiful. The process of adaptation, what is the process of adaptation? The germination of the seed takes place on the plant itself. The germination of the seed takes place on the plant itself, and after germinating the roots comes out, and the roots search for the submerged soil. Such roots, they are called as, I have given already, they are called as, what are the roots called as? Stilt roots. Why the roots are taking birth from the sidewise? Because they are having the capacity, what is called as viviparity, and so the species are called as viviparian species. What do you mean by the viviparity and what is called as the viviparity? Nothing but the seeds germinates on the body. Come on, write on there itself. They are viviparian species. The viviparian species. Seeds germinates on the tree itself. Where the seed germinates on the tree itself. This is again unique character. See, these are all the unique characters. What type of species? You can write the two species. One is called as Avicii, another one is called as Rhizopora. You can find the two examples. Okay, let me write the examples here itself. The two examples, Rhizopora and Avicenna species. Right, these are the one. What are the species? These are the two varieties of the families. What are the species? The species like Sundari. The species like Sundari species, like Agar Agar. This is Z. Agar Agar species. These are the very important species. This is about the mangroves. This is about the mangroves, very important. Why the mangroves are very important? Because they are protecting the coastal ecosystem. Why and how they are protecting the coastal ecosystem? Because of the very great winds. They will be acting as speed breakers for the cyclonic winds. Not only they will be acting as a speed breaker for the cyclonic winds, also they will be acting as a speed breakers for the fast moving tsunami waters. Right? Now, these are the areas. Add one more point. These are the species which are having very rich biodiversity. Why it is having very rich biodiversity? It creates certain what is called as a hiding space, protecting space for number of fishes, number of marine species. Not only this one, for the birds, since the trees are having very great thickness, the thick leaves, and also the bushes are very greatly distributed. Therefore, number of birds will be there, honeybees will be there. You can find nesting of so many birds. The best example, the kingfisher bird can be found here. Not only this one, you can find number of marine species. So many marine species can take shelter here in this area. Okay, these are the families. The name of the scientific the plant families. These are the families. Rhizophora and Avicenna families. What are the general names we used to call this one as Sundari tree of Sundarbans? Agar tree, again it is found in the coast of Odisha, coast of Gujarat. All these are the areas where you can find. They are having very rich biodiversity. It houses and protects, it provides a protection space for many other species like marine species, like bird species, like even some of the species like honeybees. You can find many honey hives. Snakes are taking shelter here. You can find number of amphibians here in this area. These are the areas you can find many species. The rich biodiversity can be found here. What are the areas? Come on, after this one, let us see the areas. Give the heading as the mangroves in India. Mangroves in India. What are the mangroves that are present in India? All the names are very important. Mangroves in India, very important. You can find mangroves in many areas, but in India you can find mangroves on a large scale, right? Where do you find the mangroves and what are the different names given for the mangroves in different parts of India? Write down in the form of a table, name of the state, name of the mangrove. Name of the state, name of the mangrove. The first and foremost, it is West Bengal. In the West Bengal, where the mangroves will be there at the ecotone. What is ecotone? Transition between the terrestrial and the aquatic. What is aquatic? Saline water. Terrestrial, fresh water. Wherever there is a confluence. Which rivers are getting confluence in the West Bengal area? The so-called mighty Brahmaputra, mighty Ganga and Meghna. Ganga, Meghna and Brahmaputra creates a very great mangrove area in this region. This is considered to be the world's largest mangrove region. So great a quantity of the mangrove you can find here. Some of that particular mangrove comes under the Indian territory of West Bengal. It is a West Bengal territory which is a part and parcel of India. In fact, the entire Bangladesh area, which is having a very great amount of mangrove area, some of the part comes even under the Indian territory. What is the name of this one? This is called as Sundarbans. What is the name of the mangrove in West Bengal? Called as Sundarbans. Why it is called as Sundarbans? Because of a dominant species called as Sundari tree. What is the literal meaning of this one? Sundari one. As such, in the Bengal there is no va, they are calling this as ba. Sundari ban. This is what the Sundarban. What type of species are dominantly found? It is the Sundari species. What is the uniqueness of the Sundari species? This wood is very hard but very light in nature. See this one? Hard wood but light in weight. Because of hard and the lightweight nature of the wood, this wood is extensively used for board making. The board, all the boards that are present there along the coast of Bengal, the so-called Howrah and what is called as the Hooghly River, entire region, whatever the boards you can find, all the boards are made up of the Sundari wood. This is what the unique nature. And this is the house of many other species like the Royal Bengal tigers. The Royal Bengal tigers, what is the unique nature of the Royal Bengal tigers? We feel like, they are the Royal Bengal tigers. Why the Bengal tigers needs to be called as Royal Bengal tigers? Normally the tigers are present only on the land. Tigers never can stay in the water body for a long time period. If at all they jump in the water, they will be swimming and they will be going to the other side. But why and where the species are taking shelter in the water, which type of species? The tiger species, it is the Bengal tigers. And what is the unique nature? Do you know this one? These tigers can eat the fish. They can catch the fish, they can eat the fish. This is the unique nature. That's why it's called as Royal Bengal tigers. Clear? This is the unique character of this species. This is what? Sundarbans. What type of species? You can find the species like Royal Bengal tigers. Also you can find the saltwater crocodiles. You can find number of beehives. So many, great number of beehives can be find here in this area. This is what the Sundarbans. The next one, Odisha. The next state, Odisha. The very important mangroves of Odisha, which is ecologically very, very important. Many times this was asked as a question in the prelims, but in a different aspect. The name of this mangrove is Bhitarkanika. Bhitarkanika mangrove, very, very important mangrove. This is the mangrove area where you can find the confluence of the rivers like Mahanadi river, the river like Daya river, the river like Brahmani river. See the rivers, there are certain rivers where they are draining into this area like Daya, Brahmani river. Of course, Mahanadi is however there. These are the important rivers where they are getting confluence into the Bay of Bengal, and so you can find a very great area which is called as the brackish water area, and so you can find the mangroves called as Bhitarkanika mangroves. What is the importance of this one? Suppose if this is the Bay of Bengal and this is the river, here you can find a very important island called as Kanika Island. There is an island called as the Kanika Island. If at all you are seeing the map of Odisha, then you can understand all these things. See, this is what the river, the waters are coming like this. This is the island called as Kanika. Even in Atlas you can find the Kanika Island. Along the mouth of the river where you can find the Kanika Island, there you can find in the inner reaches the Bhitarkanika mangrove regions. A wonderful area, a very great protected area. This is what the Bhitarkanika. Clear? This is the Bhitarkanika. Fine? This is about the Bhitarkanika mangrove that is found in the Odisha. What are the important species? The saltwater crocodiles. Also the species like olive ridley turtles. The species like, in the species concept will be coming to Bhitarkanika and will be explaining. But here try to understand where this particular mangrove is located. Saltwater crocodiles, right down there itself. The species that are found there are saltwater crocodiles. Also olive ridley turtles. You can find the turtles like olive ridley turtles. Clear? This is about the Odisha mangroves. One is Bengal, Sundarbans, Odisha, Bhitarkanika. Then Andhra Pradesh. Along the coast of Andhra Pradesh. The name of the mangroves is called as Koringa mangroves. Koringa. In the eastern coast of India, along the coast of Kakinada, you can find these Koringa mangroves. Very near to Kakinada. Very near to Kakinada, you can find the what is called as Koringa mangroves. Again, this is a very, very important mangrove. Then Tamil Nadu. a very important mangrove area is called as Pichavaram. Pichavaram mangroves. Also, there is another mangrove called as Vedaranyam. Vedaranyam mangroves. Very, very important. It is in this part of India where the 2004 tsunami has hit the eastern coast of India. Then the government came to understand the importance of the mangroves. When the tsunami water, see this one, this is what the coast of Tamil Nadu, this is Pichavaram mangrove. This is the Pichavaram mangrove. This is the city called as Nagapatnam. The coastline called as the Nagapatnam region. When the tsunami water came here, the people here in the Nagapatnam were killed like anything, but these mangroves protected and acted as a speed breakers, and the villages behind these mangroves has zero casualty. Then the people came to understand the importance of this one. This is what called as Vedaranyam region. There is a small lagoon area. There is a small lagoon very close to Vedaranyam. It's called as Muttupeta. Muttupeta lagoon. And so, sometimes the people used to call this one as even the Muttupeta mangroves. These are the one. Vedaranyam mangroves. Nearby to the south of Vedaranyam, you can find the small lagoon. The small lagoon area. This is the lagoon area. Probably you might have come across what is lagoon in the geography. Shall I explain lagoon or also what? What is a lagoon? Lagoon is simply an enclosed water body. The water body which is located, but almost all it is closed, but as few inlets will be there to mix the water. This is what the enclosed water body. This is called as lagoon with the shallow depths. This is the lagoon. There is a lagoon to the south of Vedaranyam called as Muttupeta lagoon, and the mangroves are also found there. Clear? This is about the east coast. Come on, write down the east coast. We will be moving to the west coast. Fine? There is a question asked by Mr. Abhishek. Recently, mangroves have been found in West Bengal, Hooghly. So, how comes they are in the fresh waters? If they are there, then how it is beneficial? What is the question? Recently, some of the people have discovered mangroves in the Hooghly river, and if at all it is river, the people general idea is it is a fresh water. How comes they are found in the fresh water? Definitely, the mangroves are present in the salt water, nothing but the brackish waters only. Whatever you have read in the newspaper or somewhere where they have discovered the mangroves in the Hooghly, it's not in the middle part of the Hooghly. It is at the part where the Hooghly is draining into the Bay of Bengal. The mouth of Hooghly is also a part and parcel of Sundarban. The waters of Bay of Bengal are entering into the deltaic region. There you can find the brackish waters. The waters are not so saline, not so fresh. In that transition only you can find the mangroves. Nowhere else, right? This is about the question of Mr. Abhishek. Is it clear? This is the Nagapatnam, this is the Tamil Nadu coast. Vedaranyam, Muttupeta, lagoon region. Fine? All these areas are very important. Then, after this one, coming to the east coast, are there any mangroves in the east coast? Are there in the mangroves in the east coast? Now, understand this one, the difference. Till now we discussed about the east coast mangroves. Are there any mangroves in the west coast? What is the height of these mangroves? The east coast mangroves are very tall and they are ranging between 8 to 20 meters. The species that are grown in this locality are of the tall of, what is the tall of this species? The tallness of the species. Anywhere between 8 meters to 20 meters. Just imagine. Anywhere between the height of 8 to 20 meters. This is what the species height. What is the height of the man? 1.5 meter. 8 meters. Even up to 20 meters. Such a tall trees are there. This is what the mangroves in the east coast, whereas in the west coast, see the west coast. In the west coast, the type of species, in the west coast, the type of species are dominantly are Avicenna. Avicenna species. Just hold on, Abhishek. We'll come to that point, okay? Avicenna species. Where do you find in the west coast of India? There you can find the species height is very, very less. They are found in the patches of Kerala, in the patches of Karnataka, in the patches of Gulf of Kutch, and there is another area called as Kori Creek. Kori Creek area and the Gulf of Kutch in Gujarat. In Karnataka it is the Kundapur region. The Kundapur region of Karnataka. Also in Maharashtra you can find off the coast of Malvan. Off the coast of Malvan, where you can find? Off the coast of Malvan you can find the mangroves. Whereas the Kerala, see this one, the areas, you need to remember the area. There is a creek called as Kori Creek. You might be knowing coming across one particular creek called as Sir Creek, which is a controversial creek between India and Pakistan. But what is a creek? Listen this one. What is a creek? See, if this is a coastal area, if the area is like this, is called as Gulf. This is what the Gulf. If this is larger, it's called as Bay. Gulf Bay. But what is the difference between the creek, Gulf, Bay? Come on, let us understand. Creek is this is what the creek is. Creek is very narrow water body. See this one, this is a very, very narrow water body. This is the narrow water body into the landmass. This is what the creek is. This is what the creek is. Could you understand the creek? This is the creek. What makes the difference between the Gulf Bay? Gulf and Bay are having the larger mouths, whereas creek, see the creek? This is what the creek is. Such a narrow projection, but elongated projection. One of such creek, which is the controversial between India and Pakistan, is called as Sir Creek issue. What the government of India did, since it is a very narrow passage, it has claimed that entire this particular, the border was drawn like this, and it claimed that entire this part is India. It claimed that its entire part is India. This is Pakistan. This is what India has said. But what the Pakistani is asking, his demand is, you need to draw an imaginary line between the water like this. If at all you are dividing the line over the water, this part of the water should belongs to Pakistan, this part of the water should belongs to India. India said as such it is a creek, it's not a bay. It's a creek, as such is very narrow. If at all you are drawing imaginary line on the water, it will be again a big controversial issue. Therefore, it is completely, it comes under the Indian scenario. This is what the Sir Creek issue, right? This is about the areas where you can find the mangroves. Very important one, Gulf of Kutch, Kori Creek, Malvan coast of Maharashtra, then Kundapur region of Karnataka, Kerala, entire area. See this entire area? This region, they are called as certain patches. The patches of these mangroves that are found not only in Kerala, the patches of these mangroves are found in the coast of Maharashtra, in the coast of Goa. In the coast of Goa, coast of Maharashtra, especially nothing but Konkan coast. Once upon a time in the Konkan coast, there were number of great swampy areas. Swampy areas. What are swampy areas? Swampy areas are those areas where they are waterlogged in condition. Once upon a time there were number of such swampy areas, but right now all they got degraded. Only in the some patches of Kerala you are finding this particular swamp. The name of this swamp is very, very important. Where do you find these swamps? In Goa, in Maharashtra. Right now they are restricted only to Kerala. What is the name of this swamp? See the name of the swamp. The name of the swamp is called as it is right now in the patches of Kerala. The name of this swamp is called as Myristica swamps. Very important. Where do you find the Myristica swamps in India? In the west coast of India. Where do you find on a great scale? Right now in Kerala. But are they only in Kerala? No, they are present even in the coast of Maharashtra and Goa also. The name of the the name of the swamp is called as Myristica swamp. This is what the Myristica swamp. Very, very important. Anything can be a question. See, we are going to the very narrow and the micro things, and we are explaining all these things. It is the approach you need to follow. In fact, what normally will be doing, the faculty duty is just will be guiding to go for mangrove, study the mangrove. Mangrove part is important, and we can go ahead without explaining all these things. I just have taken one particular topic so that you will be knowing what to read and what not to read. This is the micro level. This is how you need to study the things. Is it clear? Is it okay? Now coming to the question of Mr. Abhishek. Abhishek is not happy with the answer. Whatever the answer we have provided, like he is telling that in the Hooghly River, some of the mangroves were being discovered in the recent past. Then I said that yes, Mr. Abhishek, it has been discovered, okay, but why they are discovered? Because they are located close to the sea area or the oceanic part. The sea nothing but the Bay of Bengal, as they are closely associated to the sea area. There you can find the growth of mangroves. Why? Because the mangroves can be grown only in the, what is the water called as? Brackish waters. This is what I said. When I said this one, no sir, it is far away from the coastal area. Coastal area, I can see in the map, it is far away, and it is somewhat deeper into the land area where the mangroves were discovered. When that is the case, believe that particular area, wherever the mangroves were discovered, in that locality, the favorable climatic conditions for the growth of mangroves are there, especially the saline water. Because of some factors, other factors, when maybe the entry of the water, because of the high tides, the waters got saline, or the waters are saline water. In the saline water only there is a question of growth of mangroves, or else there is no growth of mangrove at all. Wherever they are found, that should be the condition. Without those conditions, you cannot grow what is called as the mangroves in the fresh water. Absolutely not. Because they are having thick leaves, salt tolerant, how the roots will be there? They are interlocked with each other. Could understand? Because of this one, of these characters, where they are providing very great help for the people, especially on the coastal people. You can go for catching of the fishes. You can go for the catching of the crabs, lobsters. So many are available here. The shrimps are available there. And the people of Bengal, they are very much fond of one unique fish called as Ellis fish. It's called as Elisa. The name of the fish is called as Elisa. Without Elisa, they won't eat the food at all. That is the craze. The people will be craving for that particular fish. Where that fish is available? In the Sundarban Delta. In the Sundarban Delta, the Ellis fish are available on a great scale. Clear? This is about the mangroves. Is it clear? This is about the mangrove. What is a mangrove? Mangrove is ecotone. Where the mangroves can be grown? Only in the transition ecosystem. They cannot be seen anywhere, wherever we want. Absolutely not. Is it okay? This is what all the terms that are related to the mangroves, which is otherwise the ecotone, which is having a special effect called as edge effect, and the species are called as edge species, where they are the interconnection between the two contrasting ecosystems. Fine. This is about the ecotone. Fine. How mangroves are found in Muthupeta lagoon. How salt water and fresh water meets in lagoon as it is enclosed. It is a salt water lagoon. Could understand? Tushar has got the doubt like Muthupeta lagoon is there. Lagoon, how comes lagoon? There is no interconnection, but there is no inflow of salt water and the saline water. How comes there is the mangroves there? It is a salt water lagoon. In fact, it is the area along the coastal area. It is along the coast. Suppose if this is the coast of Bay of Bengal, where the lagoon is there, the lagoon is present here like this. This is what the lagoon. This is the connection. This is the lagoon, Muthupeta lagoon. The entry of the saline water into the landmass. This is what the lagoon, where the closure nature is there. Here you can find the mangroves, the Muthupeta mangroves, right? Without saline water, without, not too saline, it should not be too saline, it should be brackish, right? This is what, on the land you can find the fresh water, but you can find the entry of the saline water here. Therefore, the water becomes somewhat fresh, somewhat saline, intermediate. Wherever the intermediate nature is there you can find the mangroves. All these areas are the very far, most sought after places. Clear? This is about the, fine? Then, after this one, the next one is called as ecocline. The very simple topic regarding another particular word which is closely associated with the ecotone is ecocline. Come on, give the thing as ecoclone. Fine? Where do you find ecocline? Come on, let us see the ecocline. Where do you find the ecotone? The conjunction, wherever two contrasting ecosystems are there. Then, point number one. Second one, such a overlapping is called as edge effect, and the species is called as edge species. Fine? Now, coming to the next one, called as ecocline. What is ecocline? Come to this point. Whenever you are seeing the transition ecosystem, like suppose if this is the area, this is the area where you can find ecotone. This is ecotone. Clear? This is a transition. Now, suppose if this is a mountain. Suppose if this is a mountain. What type of changes you can find? Altitudinal changes. You can find the altitudinal changes, right? As and when the altitude changes, what happens to the climatic conditions? The temperatures reduces, pressure reduces, availability of the water reduces, all these things are keep on reducing. Because of this one, what happens as and when you go to the top of the mountain, the vegetation will be keep on changing, right? If at all you are climbing the top of the Himalayas, do you find the same broadleaf vegetation right from the foothills to the top of the Everest? No. As and when you go, first of all at the foothills you can find the broadleaf vegetation. As and when you go to the top, you will be somewhat seeing the less vegetation than that of the foothills. Then you can find a unique type of species called as the coniferous vegetation. After the coniferous vegetation, you can find the coniferous grass. The coniferous grass, nothing but the alpine grass is present there. After the alpine grass, you can find the rhododendrons. Probably you might have come across in the natural vegetation. Come on, I am giving the, let me give this one. Come on, ecocline. If at all you are seeing the vegetation, this is called as the broadleaf vegetation. What is this broadleaf vegetation? You can find up to a height of 1500 meters. Up to a height of 1500 meters, you can find the broadleaf vegetation. Beyond this one, you can find up to 3000 meters, you can find what is called as the coniferous vegetation. To the type, whenever you are moving vertically up to the mountain slopes, along the slopes of mountains, what happens? At the foothills, because of more photo energy, more water facility, very good amount of nutrients in the soil. Why nutrients are there in the soil? Because whatever the soil that forms on the top will be washed down to the foothills. Therefore, you can find good amount of nutrients that are available at the foothills. Therefore, you can find good growth of vegetation. What type of vegetation? Broadleaf vegetation. As and when you go to the top, since the temperatures becomes low, availability of the water becomes low, therefore you can find coniferous vegetation. As and when you go up to the height of 4500 meters, you can find a grass called as alpine grass. Up to 4500 meters, what you can find? Alpine grass. No trees. Trees have given way for grass. Why the trees are not grown, only grass is grown? The availability of the nutrients in the soil, the availability of the photo for the plant, availability of water for the plant is sufficient only to the growth of the grass. Could understand? What you can find at that particular height, there is no tree. Why the tree is not there? Because of less photo, less water, less nutrients in the soil. The grass can be grown. Beyond this one, up to a height of 4800 meters or even 5000 meters, what you can find? Only the type of species called as rhododendrons. Rhododendrons. What are these rhododendrons? There are small shrubs. Very small shrubs. You can pluck that one. If at all you are crushing, it will be giving so great juice. That very juice is very good for our heart diseases. It's a medicated plant. That plant is basically found in the regions like Canada. Also in the upper reaches of Himalayas. Rhododendrons. These are the rhododendrons. Beyond this one, you can find what is called as the snow line. Is it clear? This is the vertical distribution of vegetation along the slopes of the mountain. All these things, these are known to you. I don't want to enter into this one, right? This is a snow line. This is a snow line. Beyond this one, you can find the snow. Below the snow line, you can find rhododendrons. Below this one, you can find the alpine grass, then coniferous trees, broadleaf vegetation. Now, what is ecotone? See this one. This is the order of availability of the vegetation along the slopes of the mountains in the Himalayas, right? What is a ecotone? Ecotone is nothing but within some same area, as and when you are moving ahead, whenever there is a change in the species composition, whenever there is a change in the community composition, such a differences between the two ecosystems is called as ecocline. Nothing but it is also a transition but along a gradient. Got the point? If the transition is there along a flat land where the contrasting ecosystems are there, they are meeting. If they are intersection, the intersection of this contrasting ecosystem horizontally is called as ecotone. What is that same intersection of the contrasting ecosystems along a gradient is called as ecocline. Is called as ecocline. This is what the ecocline is. Hope all you people are very clear. Is it clear? What is ecocline? Ecocline is nothing but again a transition but along a gradient. Write on ecocline. What is ecocline? Ecocline is a zone of gradual. Ecocline is a zone of gradual. Ecocline is a zone of gradual but continuous change. Gradual but continuous change along a gradient. Along a gradient. Along a gradient, especially altitude. Along here, along the altitude. Fine? Draw this one. Show that in between any two ecosystems, you can find the ecocline. Is the gradient. This is what the gradient, nothing but altitude. Write down, if at all you are having confusion in the gradient, you remove the gradient and write as altitude. Along an altitude is called as ecocline. Is it clear? Sir, what is this alpine grass in Jammu and Kashmir called as? Very important again. In the Jammu and Kashmir, the special name is there for this grass, alpine grass. These are called as murgs. In Jammu and Kashmir, specifically the people of Kashmir are calling this one as alpine grass as murgs. The best example. These are the very important hill stations. Gulmarg, Sonmarg. What is Gulmarg? Nothing but marg is the alpine grass. Nothing else but the grasses can be found here. This is about the Gulmarg and the Sonmarg. This is ecocline. Fine? Is it okay? Here we will take a small break. After the break, we will start the next topic, which is called as the functions of ecosystem. Very, very important. Okay? We will go for a small break, give the heading as functions of ecosystem, then we will start the functions. Yes, welcome back. Yes, good. Can mangrove act as an indicator species? No. There is no question of indicating. Okay. They won't indicate. In fact, they are the one where they are protecting the coastal ecosystem, but they are not indicating anything, right? Is it okay? Now, after this one, let us move to the larger concept. Come on, let us enter into the other concept, which is called as yes. Let us move to the next very important one. Functions of ecosystem. Come on. Functions of ecosystem. Though we are going slow, but we are going in a very, very clear manner. See, the basics are very important. Like, the other concept, like where do you find which type of site, there I can move somewhat a little bit fast paced, but here I will be going very slow because you need to have a conceptual clarity. Okay. Now, move to the next one called as the functions of ecosystem. What are the very important functions of ecosystem? Write down the function. The first and foremost function of ecosystem is called as energy flow. The very, very important function of ecosystem is energy flow. Because of this flow of energy only, ecosystem become very important, and so ecology and so environment. Had this energy is not flowing from one level to other level, there is no question of life at all. This is a very, very important function. The very important function of ecosystem is the flow of energy. How the energy flows? Flows in the form of food chain. Flows in the form of food pyramid. Sorry, food web. In the form of food chain, food web. Within the energy flow, we will be talking about some other things like the concept like there is a rule called as 10% rule. A very, very important rule. It's called as Linman's 10% rule. Very important. Then we will be talking about what is called as the ecological pyramids. Ecological pyramids. After this one, we will be entering into the next one, which is called as the very another important one is called as ecological productivity. Ecological productivity is the productivity. The next one, ecological succession. Then biogeochemical cycles. Biogeochemical cycles, where they are nothing but the nutrient cycles. Then the last very important function of ecosystem in order to maintain the equilibrium called as the nature as such, it is balancing its plus and the minus. Nothing but whatever the yields that are happening are being maintained by the positives, and the positives are again impacted by the negatives, and so the earth is maintaining a uniformity, a equilibrium. That self-equilibrium mechanism. This is a self-equilibrium mechanism. What do you mean by the self-equilibrium mechanism in the ecosystem is called as homeostasis. What is this one? We will be discussing. Clear? These are the functions of the ecosystem. What are the functions? The first and foremost is called as energy flow. Within this one, we will be seeing the food chain, food web and all the other things. Then the ecological productivity, succession, then biogeochemical cycles, homeostasis. After this one, all these things have been done. The last one, which is very, very important one, the connecting topic to this one is called as ecosystem services. Within this one, okay, we will be talking about ecosystem services. There you will come across a very important organization called as TEB. This is what the structure will be following. Come on, make note of this structure. Make note of this structure. We will be following the same structure. In the same order we will be going. What do you mean by TEB? What do you mean by ecosystem services? What is the homeostasis? This is the structure we will be following. This is one concept, right? Now let us start with the first one, energy flow. Come on, give the heading as energy flow. First listen, then we will talk about the dictation. First listen. What is the first and foremost function of ecosystem? It is energy flow. Is a very prime important of the ecosystem is the flow of energy. If the energy is not flowing from one level to another level, there is no question of life at all. This energy, since energy cannot be created, not destroyed, but can be converted into other form, based on this principle, what is happening? The entire energy for the earth, the source of energy, see the source of energy? Whenever you are seeing the source of energy is the sun. When the sun's photo energy is observed by the leaf, see the leaves are absorbing the photo energy, and what they are doing, they are converting the photo energy into chemical energy. They are converting the photo energy into chemical energy. This is a very important step where the life is happening on the surface of the earth because of this step. Now understand this one, how it is happening. It's not so simple mechanism just by absorbing the solar energy where the energy is being converted. Whenever you are seeing the energy that is being sent by the sun and the energy that is received by the earth, and the received energy how much is having the potential to convert the photo energy into chemical energy, if at all you are seeing this one in the form of a numbers, then we can understand how sensitive the life is there on the surface of the earth. Our life here on the surface of the earth is very, very sensitive. So sensitive part. If something misbalance happens, the life will get perish here. The life is very, very sensitive on the earth. How sensitive? Come on, understand this one. When the sun, if the sun is sending 100 units of energy, understand in terms of units, so that whenever the number is given, then only can understand the importance and the sensitivity of the life forms that are present here on the surface. When the sun is giving 100% of energy, how much energy is received on the surface of the earth? Because of the distance between the sun and the earth, and because of the size of the earth. What is the size of the earth with respect to sun? Whenever you are there, if I assume that you are there on the sun, and if you are searching for the earth, if you search for the earth is not visible at all. That is the size of the earth. We cannot see the earth with our naked eye from the sun. So small dot is the earth. With such a small dot, this particular earth is capable of receiving only 51 units. If sun is giving 100 rupees, earth is having capacity to take only 51 units. Is this 51 units is completely utilized by the plants? No. This is called as PAR. What is PR? Let me give like this. Instead of going to PR directly at technicality, let me explain further and then we'll come to the PR. Out of these 51 units of energy, what the sun ray is having? Sun ray is having a spectrum, right from the high band value till the low band value, like UV rays, X-rays, infrared rays, then to the small waves also. Okay, this is what the spectrum, all you people are aware of the spectrum, right? Within this one, there is a visible light, the light ray. Within that one, that particular light energy is the one which is useful for the photosynthesis. This part of the, within the spectrum of the sunlight, the part of the sunlight which is useful for the photosynthesis is called as photosynthetically see this one. The part of the sunlight which is helpful for the photosynthesis is called as photosynthetically active radiation. It is called as photosynthetically active radiation. What is this photosynthetically active radiation? Which is nothing but, out of these 51 units, how much of energy is there? Just 2% to 10% of energy. Out of this entire light ray, whenever you are seeing the light ray, you can find different types of the wave energies, like ultra wave energy, infrared wave energy, then you can find cosmic rays, X-rays, so many rays. It is called as spectrum, right? Within the spectrum, only the light, that is energy, the light wavelength, which is around some 200 to 700 wavelengths, only this is called as the photosynthetically active radiation. Out of entire sunlight, how much is having the potential to be converted from the photo energy into chemical energy is called as photosynthetically active radiation. This 51 units is not completely utilized. Out of these 51 units of energy, within this 51, in the bandwidth of 700 to 200 only, within this one, only 2 to 10% of energy can be consumed by the plants. This forms the total energy for all the life forms on the earth. This very 2% to 10% of the energy that can be utilized for converting photo energy into chemical energy, this is the basic energy for all the life on the surface. Whenever you are seeing the life, so many varied varieties of lives are there. All these lives are having the energy only from this 2 to 10%. Got the point? Only this 2 to 10% of 200 to 700 wavelength out of these 51 units of energy is utilized. This energy is called as PAR energy. What is PAR? Photosynthetically active radiation. Entire sun's energy is not active for photosynthesis. Only certain part of the sun's ray is utilized. Is it clear? This is called as the PAR energy. Fine. This energy, now understand this one. Now what happened? The leaf has produced the energy. Now the leaf is having the energy. This energy can be consumed by some of the species. If at all you are talking about the names that are there in the ecology, as they are producing the food materials, they are called as autotrophs. What are those things which are producing the energy? It's called as autotrophs. Auto, self, trophic means what? Having the food. Self preparation of the food material. This is what called as autotrophs. Who are autotrophs? It is those plants which are having chlorophyll. Those plants which are having the chlorophyll are called as the autotrophs. The moment once they produce, where the leaves are consumed by insects, rabbits, then you can find the ants. You can talk about so many animals where they are directly feeding on the green leaves. When the insects or any other creature, whenever it is feeding on the green leaves or the green grass, where they are called as the primary consumers. They are the primary consumers. See here, slowly, already we have given these names. Now I am connecting these names to the concept. Come on, let us see this one. These primary consumers, they are otherwise called as herbivores. These are called as herbivores. All these things already have given the names, right? Now, after herbivore, then this very herbivore may be a rabbit, maybe a deer, maybe a frog, whenever maybe some of the insects, okay, if not frog, maybe take it as insect, okay, where they are consumed, whenever they are consumed, they are called as the secondary consumers. The secondary consumers, whose energy is coming from the primary consumer to the secondary consumer, it is the plant energy. The plant has stored certain energy, that energy is transferred. The animal has stored certain energy, that animal energy is transferred here. This is what called as carnivore. This is called as the carnivore. When the secondary consumer is also consumed by some other species, like tertiary species, tertiary consumer, where they are called as omnivores. Right? This is what is happening, right? This is what the structure. This is the one where everyone is well aware of. Already I have given some 2 times. I have given the same concept for 2 times. Is it okay? Okay, this is what the condition, right? If this is the one, what is happening here? The energy that is produced by these elements, like these living creatures, the energy is being transferred from here to here, here to here, here to here. Each and every level where the energy is being transported from one segment to another segment is called as the trophic level. The trophic level. This is what called as the trophic level 1. This is called as the trophic level 2. This is what called as the trophic level 3. It's not the species, it is the position of the species. It's not the species, it is the position of the species where it is located, right? It is trophic level number 4. What is happening? It is all the time from the trophic level 1 to trophic level 2, the energy is moving. Is it clear? The trophic energy is moving from the producers to the consumers. Every time, the moment whenever the energy is being transported from one level to another level, from one trophic level to another trophic level, how much of energy is transported? It is only 10% of energy is being transported. What are these trophic levels? Nothing but, this trophic level 1 is nothing but grass, maybe the green plant, which is having the capacity to produce the food, and it has produced. Say it has produced 100 units. Out of 100 units, it is storing for its own purpose some percent of energy. Maybe the plant has utilized the sun's energy on a great scale and it has produced certain energy, and it has utilized the energy, and has kept for its own purpose. When it has kept the energy for its own purpose, some other fellow is coming and consuming that energy. He is looting, he is taking off. The moment when the energy is taken, snatched off from this one, how much energy that particular creature is sending to another creature is only 10%. From this trophic level, when the energy is being transported here, how much of energy is transported again? Again it is 10%. Again from this one, from the trophic level to trophic level 4, how much of energy is being transported? It is only 10%. This is what a very great discovery done by a very great ecologist by name Linnemann. The name of this guy is a very great ecologist called as Linnemann. This is called as Linnmann's 10% rule. What do you mean by Linnmann's 10% rule? From every level to another level, whenever the energy is transported, since the energy neither created nor destroyed, it can be transferred, can be converted. How much of energy can be converted? In this case of living creatures, it is only 10%. What is happening to the remaining 90%? The 90% of the energy is lost in the atmosphere. 90% of the energy is lost in the atmosphere. This is what he said. Means what? What do you mean by this one? How the energy has been transported from one level to another level in a perfect order. This type of movement of energy in a perfect link-like structure, this is what called as food chain. First of all, listen, don't write anything, we will be dictating all these things. It's called as food chain. What is a food chain? The movement of the energy, nothing but the food here, in the form of a chain from one level to another level. Energy is not stored exactly at one place. It is keep on moving from one place to another place. Means what? From one species to another species. This is what is happening. In this one, whenever it is moving in the form of a link, where it is called as the food chain. These food chains are of two types. One is called as the grazing food chain. One is called as the grazing food chain. Another one is called as detritus food chain. One is called as grazing. Another one is called as detritus food chain. What is a grazing food chain? Grazing food chain is such a food chain where it starts with the green plants. Grazing food chain starts with the green plants. Maybe the best example, grass, or maybe a small shrub, or maybe a plant. And the plant is being consumed by, when the plant is consumed by maybe one species called as deer. Then the deer is consumed by a tiger. This is what the movement of flow of energy. Starting with the grass to carnivore, the higher level species. Such a simple chain of movement of food from one level is called as food chain. Each and every stage, see the each and every stage, at each and every stage, what is the stage where this is not the species, it is the energy for the next stage. This is what called as trophic level 1. This is trophic level 2. This is trophic level 3. It is not the animal that is important, it is the flow of energy is important, how the energy is been moving. Is it clear? This is what called as trophic level 1, trophic level 2, trophic level 3. If the chain of energy, if it starts from the plants, it's called as the grazing food chain. This is what the grazing food chain. What Mr. Linnemann said in this one, the Linnemann has said that Linnmann's 10% rule. What this Linnmann's 10% rule says? From any trophic to any trophic level, whenever the energy is being transported, it is only 10% of energy movement takes place. How much of energy is being transported? Just 10%. Now, understand this one. Only 10% of the energy is being transported. Now see this one, very very important one. If the plant is having 100 units of energy, how much the deer will be getting? 10 units of energy. How much tiger will be getting? Just 1 unit of energy. What is tiger? Such a high, which is a high level animal. It requires more and more energy. When it requires more energy, and if it is getting only 1% or nothing but the 10% of energy from the lower creatures, it can't satisfy its appetite, it can't satisfy its demand for the energy. Therefore, it will be having a different sources of energy gathering. Such a different sources of energy gathering makes what is called as food web. Why food web is necessary? Food web is necessary because of the survival of the apex creatures. Had this web of nothing but, what is web? Web is nothing but network. What is web? Web is nothing but network. If the network of the food chains is not available, the apex creature cannot survive. Therefore, as a condition, the apex creature, what they are doing, they are searching for various sources, different sources. When all these sources are networked, what it forms the food web. Is it clear? Now, see this one. What is happening here in the case? What is happening here, case? The plant is consumed by the deer is consumed by the tiger. Now, when the consumption of the deer by the tiger, it is getting some what energy? Less energy. Therefore, it requires more energy. Therefore, what it will be doing? It will be eating some other creatures, like maybe the plant is being consumed by a rabbit. Rabbit is also consumed by this one. Maybe the plant is eaten by a chick. Chick is being consumed by this one. Therefore, from different sources, whenever the energy is coming, where it is called as the network of food chains. If there is a network of food chain, such a network is called as food web. This is what the food web. This is about the food web in the grazing food chain. Then what do you mean by detritus food chain? The detritus food chain is the one which starts with a dead organism. Come on, understand this one. If at all it is happening with the plant, where it is a autotroph, it is called as the grazing food chain. If the food chain start with the dead organism, like what is the dead organism? This is a dead body, maybe a dead body of animal, dead animal. Instead of dead body, write it as dead animal. If it is dead animal, over the dead animal, someone will be feeding. Who is that someone? Maybe the vultures or hyenas, or else you can find some of the creatures like worms, earthworms, where they break the complex organ into the smaller parts. That particular material which got broken into smaller parts again will be recycled into the autotrophs. Who will be absorbing this one? The humus, where they will be creating the product called as humus. When the humus is created, who will be absorbing the humus? Again the plants will be absorbing the humus. Means what? There is an interconnectivity between the grazing food chain and the detritus food chain. This is what the interconnectivity that is there. When the animals are being broken from the larger size into the smaller complex, from the complex sizes into smaller products, whenever they get mixed into the soil, again they are being absorbed by the plants, and again they convert the photo energy into chemical energy. They grow in size, supply the food for other creatures. This is how the two food chains are interconnected. The network of such a food chain is called as the food web. This is what the chain of energy that is happening. In this chain of energy, what is very, very important is each and every level from where the food is, the energy is the energy is acting as a bank there, from where this energy bank is being supplied to other bank. What is the level from one level to another level is called as the trophic level. What is the trophic level? The source of food. Whenever the food is being transported, nothing but energy is being transported. The energy is transported from one level to another level. Such a chain, in this chain, how much of energy takes place? Only 10% of energy. Like we people, just imagine like this. Suppose if there is a paddy. If there is a paddy and the paddy has produced one bulb, one particular rice of rice, the bulb of one rice, nothing but one paddy, how much of energy is there? 100% energy is there. If at all you are consuming, how much of energy we can consume? Only 10%. Means what? 10% of energy is being given us. One bulb of paddy gives 10% of energy. That's why we never eat only one. We'll be taking only one and we'll be satisfying our appetite. No, we'll be eating so many. That 10% will be keep on consumed, and therefore we are getting so much of energy. Got the one? What is the energy required? The higher level, the apex level, more energy required. Therefore, one product which will be giving only 10%, we require more number of such products and will be consuming more. This is what the 10% law. What happens to this 90% of energy? Now see this one. When the tiger is eating the deer, is the deer is waiting for the tiger to come or what? For this deer to be caught by the tiger, it will be running. For that it requires energy. Breathing heavily, it requires energy. It has to tear the deer, energy is required. It has to pull out all the muscles, energy is required. Then it will be eating. The moment whenever it is in respiration, more and more respiration, for this one it requires energy. Digestion, for this again it requires energy. Though it is consuming more than what Lindemann said as 10%, all the 90% is utilized by the tiger, and how much is stored in the body of the tiger? Just 10% of energy. Therefore, how much of energy got transferred? Just 10%. This is what the concept of Lindemann. A very great ecologist who has given a very great clarification regarding the transfer of energy. Where the transfer of energy calculation is very, very tedious job, and it was made very simple by Mr. Lindemann. Therefore, the rule is called as Lindemann's 10% rule. How much of energy is transported? Just 10%, right? This is about the what is called as the energy flow. Come on, let us see again. Okay, this is about the energy flow. Come on, write down, take down the notes. Yes, what is after the, in the detritus, what is given? Worms. Worms was written. Maybe that was not clear, it seems. Let me write again. That was not that much clear. Where I have written, let me cut that one and let me write this one. Okay. Earthworms. Is it okay? Is it clear? Fine. This diagram is very important. Means what? This structure is important. Yes. Come on. Write down the notes. Energy flow, come on. Energy flow in an ecosystem. You are writing as functions of ecosystem. What are the different functions? I hope all you people have written those functions. Like One is called as energy flow. The second one, where is that one? Yes, these are the 5. One is the energy flow. Come on, write down these things. Functions of ecosystems. I hope all you have written this one. Yes, the first one, give the side heading as energy flow. Give the heading as energy flow. The flow of energy, the flow of energy, the flow of energy from one level of species to other level of species takes place in the ecosystem. The flow of energy from one level of species to another level of species takes place in an ecosystem. Full stop. This energy is cycled energy is cycled in the ecosystem. The sun is the primary source of energy cycled in the ecosystem. The sun is the primary source of the energy. The sun is the source of energy for all the ecosystems. Of all the ecosystems, full stop. Out of the available solar radiation, it is only 50% of the solar energy that is useful for 50% of the solar energy useful for photosynthesis. This energy is called as PAR. This energy is called as PAR, photosynthetically active radiation. This is called as PAR, photosynthetically active radiation. The plants capture only 2 to 10% of PAR. Plants capture only 2 to 10% of PAR. Full stop. The plants capture only 2 to 10% of PAR. This energy is transported, along the hierarchy of the ecosystem. Hierarchy of the ecosystem. Each and every stage, full stop, each and every stage of this hierarchy is called as trophic level. Each and every stage of a ecosystem is called as the trophic level. Is called as trophic level, side trophic level. Side trophic level. Give the heading as trophic level. What is the definition of the trophic level? Come on. The trophic level of an organism, the trophic level of an organism is the position it occupies in the food chain. The trophic level of an organism is the position it occupies in the food chain. The position it occupies in the food chain. Full stop. The trophic level is the number of steps an organism is from start to the trophic level is the number of steps 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 an organism is from start of the chain, is from start of the chain, is from start of the chain. Full stop. Producers, full stop, producers or the autotrophs forms the base for the trophic level. Producers oblique autotrophs forms the base of the trophic level, and the energy flows successively from one level to another level. The energy flows from one level to another level successively. Full stop. Such a successive movement of energy is called as such a successive movement of energy from one trophic level to another trophic level. Such a successive movement of energy from one trophic level to another trophic level is called as food chain. Is called as food chain. Side heading food chain. Side heading food chain. Side heading food chain. It is a chain of organisms. It is a chain of organisms existing in any ecosystem. Existing in any ecosystem through which energy is transferred. Existing in any ecosystem through which the energy is transferred. Full stop. There are two types. One, grazing food chain. Two, detritus. Grazing food chain. Second one, detritus food chain. DETRITUS, detritus food chain. Side heading grazing. Side heading grazing food chain. It begins with the green plants. It begins with the green plants, oblique autotrophs. Oblique autotrophs. Full stop. The energy and nutrients move from autotrophs to consumers. Autotrophs to consumers. Then side heading detritus. Detritus food chain. It begins with the dead organic matter. It begins with the dead organic matter. It begins with the dead organic matter which is broken into smaller material by the decomposers by the decomposers which are further consumed by which are further utilized in the grazing food chain. Write down like this, which are further utilized in the grazing food chain. Further utilized in the grazing food chain. Side heading food web. Side heading food web. It is a network of interconnected food chains. Side heading food web. It is a network of interconnected food chains. It is a network of interconnected food chains so as to form the number of feeding relationships. So as to form a number of feeding relationships among different organisms. So as to form number of feeding relationships among different organisms of a community. Then side heading 10% rule. Give the side heading as 10% rule. Give the side heading as 10% rule. This rule is propounded by Lindemann. The rule is propounded by Lindemann, Lindemann, and so often called as Lindemann's 10% rule. Propounded by Lindemann, Lindemann, and so often called as often called as Lindemann's 10% rule. It states that the amount of energy decreases at successive trophic levels. It states that the amount of energy decreases at successive trophic levels. Amount of energy decreases at successive trophic levels, full stop. It is only 10% of the energy. It is only 10% of the energy is transported. It is only 10% of the energy is transported from one trophic level to another trophic level. One trophic level to another trophic level. From one trophic level to another trophic level. One trophic level to another trophic level, and the rest 90% is lost. And the rest 90% is lost. And the rest 90% is lost in the environment. The rest 90% is lost in the environment. The rest 90% is lost to the environment or to the environment in the form of rest 90% is lost to the environment in the form of respiration. in the form of respiration. In the form of respiration. Right? Now, give the heading as ecological pyramids. Come on. Give the heading as ecological pyramids. Give the heading as ecological pyramids. Give the heading as ecological pyramids. Give the heading as ecological pyramid. Come on, give the heading as ecological pyramid. What do you mean by ecological pyramid? Come on. What is ecological pyramid? Listen this one first of all. You can see the screen after some time. First of all, listen. What is ecological pyramid? What is the significance of this ecological pyramid? Understand this one. Wherever you see any material, you will be coming across the material which is talking about, yes, the structure is arranged in the form of a pyramid which is called as ecological pyramid. But what is the significance? What is the significance of the ecological pyramid? Understand this one, very, very important. If at all you are moving to any protected area, maybe a national park, maybe a wildlife sanctuary, maybe a biosphere reserve, normally the ecologist, how they can identify the health of that particular protected area? Not by seeing the area, how many trees are there, not by seeing the tigers, how many are there, but by seeing the pyramids. The pyramids are called as the ecological pyramid. What that pyramid denotes? That pyramid denotes what is the health of the ecosystem. That pyramid denotes what is the biological diversity of the ecosystem. That pyramid denotes how far it is going to have the life, how much time period this particular ecosystem can survive, how far it is providing the food for any other life form. What is, this point is very important, what is the carrying capacity of the region? What it denotes? It denotes the carrying capacity of a region. Come on, pay attention. Very, very important. What is this one? It denotes the carrying capacity. Come on, let us understand this one. What it denotes? It denotes the carrying capacity. Now suppose if there is a screen. Now understand this one. Whenever an ecologist is moving from one ecosystem to another ecosystem, what he can read is not seeing the entire ecosystem going in that area, how many trees are there, how he won't be calculating. He simply sees, he will simply ask the forest department to bring what is called as the ecological pyramid. When he is talking about the, when he talks about the pyramid, Just by seeing the ecological pyramid, he can understand the health of the area. Just by seeing he can understand the health of the area. Let it be. 1 second, okay? Let it be. Can you write this one? You cannot write. You cannot write on this one. Last time I have used the same screen for writing also. What is the ecological pyramid? Come on, let us see. Yes, now it came. Yes, very good. Okay, what is the ecological pyramid? Now understand this one. What is this ecological pyramid? Yes. What is the ecological pyramid? Understand this one. The representation of ecological pyramid. What is ecological pyramid? It's a graphical representation of the relationship between different organisms in an ecosystem. What is the ecological pyramid? What is the ecological pyramid? Nothing but it's a graphical. Understand the concept. Don't write anything. Listen. Understand the concept. Graphical representation. Graphical representation of the relationship between the number of species. How the species are interrelated. Is a graphical representation of the relationship between different species in an ecosystem. You take any ecosystem. Suppose if this is any ecosystem. If at all you are taking any ecosystem, how one species, suppose this is one species, how it is interrelated with other species? Because each and every species is having some interaction. When they are interacting with each other, what is that interrelation that is there? If you represent the interaction, interdependencies in a form of a graph, that graph represents a triangle-like structure. Such a triangle-like structure is called as ecological pyramid. Means what? Say for example, if at all you are taking the best ecosystem as forest. What are the components of the forest? You can find the animals, you can find the trees, you can find so many species, right? Say for example, if at all I am representing all these species like this, suppose this is the plants, and I want to see, plants means what? Nothing but the grass related components, right? Grass is there. And I want to see which are the species that are primarily depending upon this grass. Maybe the next one is called as the deer. The deer is consuming the grass continuously, and therefore the deer population is growing in size. Whenever you are literally seeing the area of the forest and number of deers, deer population is less than that of the grass that is available, and within this area you can find the other species which is called as the tiger. Maybe one tiger is present in locality, 10 deers are there and 100 trees are there. If at all I am representing these numbers, one tiger, 10 deers, 100 trees are present here in this area. If I represent in a form of a graph, this graph appears just like what is called as a triangle like this. This appears just like a triangle. This is what? The triangle. This graphical representation in the form of a triangle, this is called as ecological pyramid. This ecological pyramid is highly significant for many other aspects. Just by seeing the pyramids, you can understand whether this particular area is having a very great capacity to hold the population of a new species. Recently, the government of India started introducing the cheetah species in India. Even the Supreme Court also gave the green signal to introduce the cheetah in the one of the particular national park of India in the Madhya Pradesh, right? These are the developments that are there. Why that particular species like cheetah needs to be introduced in that particular area? Why not? It can be just released into India right from Kanyakumari till Kashmir. Who will be giving the information for where this particular species can be introduced? It is the pyramids, because pyramid represents the health of the area. The pyramids represents the number of species in that area. The pyramid represents how much productivity is happening in that region, how much ecological productivity is happening in this region. It also talks about what is called as the carrying capacity. The carrying capacity of a ecosystem, very, very important. What is this carrying capacity? Come on, understand what do you mean by carrying capacity. Understand this one? This is very, very important. What do you mean by carrying capacity of any region? Suppose if this is a region, you consider this as maybe forest, maybe grassland, whatever you want to consider, you consider this one. Maybe a geographical area like the state of Uttarakhand. You consider this as Uttarakhand, or you consider this as Jammu and Kashmir, whatever you want to consider, it is up to your imagination. This is one area. Every area, because of its components like land, nothing but soil and the related things, like water, the water that is available, like moisture, soil moisture, atmospheric moisture, then the rivers that are flowing, like the gases that are available like oxygen, nitrogen, carbon, whatever the gases that are there. With all these resources, this particular piece of land is capable of allowing only 100 species, where these 100 species can live indefinitely. This is what called as the carrying capacity of this region. This is the carrying capacity of this region. What is the carrying capacity of this small area? 100 species only. Maybe 100 tigers or 10 tigers, 20 lions, 30 elephants, all put together 100. Only it is having the capacity of 100 species only. Clear? This is what called as the carrying capacity of this region. Who will be deciding the carrying capacity? The abiotic factors that are located. Right? The abiotic factors are the one which are deciding the carrying capacity of that region, where they are producing the food material for only this many number of species. Right? This is called as the carrying capacity. Each and every area, each and every piece of land, each and every area, entire locality, each and every region, each and every zone, for that matter, entire earth is having limited carrying capacity. Every area, every region, every zone, even the earth is having limited carrying capacity. The earth is having the limited carrying capacity of only this many population. Whenever this number of species are being overshooted, now within this area there are 200 species. Because of increasing of the population, what happened? The 200 species got included. Then what happened? Beyond the carrying capacity, the region is holding the species. Beyond the carrying capacity, the region is holding the species. And these 200 species are living in this area with lot of difficulties. Yet they are living. Yet they are surviving. Right? The moment when this particular number from 200 starts growing to 400. What happens? This carrying capacity collapses. The moment when the carrying capacity of a region collapse, the moment when the carrying capacity of a region collapsed, there are no facilities for the species available in that locality to survive. Then it leads to this area, leads to all. Then this area leads to all sorts of disasters. The disasters are but inevitable. When the disasters are inevitable in that area where the carrying capacity got lost, this is what called as the losing of the carrying capacity of a region. based upon this one only, where UPSC has given some of the questions asking in the mains like, do you think that the Uttarakhand region has reached its carrying capacity because of number of floods it is witnessing? This was the question that was asked. The carrying capacity of the Western Himalayas is about to reach. It has reached. That's why disasters are but common. This is what the carrying capacity. What is the concept? The concept is called as the carrying capacity, right? If you know the carrying capacity, then you can understand and you can allow the people, allow the species to stay in that area in a limited sense. Where the government of India wants to release the cheetahs, wherever the region is having the carrying capacity. Where the government of India under the concept called as Rhino Vision 20, Rhino Vision 2020. This is the program. This is a program where the government of India has introduced way back in the year 2015, and the program continued till 2020. They want to increase the population of the rhinoceros, and they have introduced the program called as Rhino Vision 2020 to increase the number of the population of the rhinos. But they came to know that the area which is called as the Kaziranga National Park, it is reaching its carrying capacity. When the area is reaching its carrying capacity, now they can't increase the carrying capacity. Therefore, the animals are translocated. When the area reached its carrying capacity, now we need to reduce the burden on that area. How to reduce the burden on this area? Remove the species from that locality and introduce the species in some other locality. This is called as the translocation of the species. And therefore, right from the Kaziranga National Park, the rhinoceros are carefully translocated to Manas Biosphere Reserve, Pabitora National Park, then Dibru-Saikhowa region, Orang National Park, all they are there present in Assam. Question can be asked like this. The Kaziranga National Park has reached its carrying capacity. What are the solutions? Please suggest. We suggest what is happening right now? The animals are being translocated. Is the concept clear? Now, if it is clear, if the concept is clear, now come to the concept. Another question like, what is the question? See the question. Now I am going to ask a question. This is not area, this is earth. Now this is earth. If an area is reaching its carrying capacity, we can translocate the species. Suppose if the earth reaches its carrying capacity, what happens? What happens? What happens whenever the earth is reaching its carrying capacity? Do you think that earth has not reached the carrying capacity by this time? Right now, the concept is called as, see the concept. The concept is called as Earth's overshoot day. What is this Earth's overshoot day? The ecologists are believing that the Earth has reached its carrying capacity. Any further addition of the species, any further degradation of the resources, any further pressure on the resources will degrade collapse entire ecosystem of the earth. This is what the people are believing. And they said that they have calculated, yes, they have calculated saying that when the earth reaches its overshoot day, means what? When the earth is not having the carrying capacity, then the disasters are must. Disasters are must. And we have witnessed the disaster in the form of see, this is what some of the people are believing. Some of the people are explaining like this one. Why there are certain pandemics, and this is the beginning. What the people are telling, this is the beginning. This is not the end of the story. This is the beginning. This is the sample. In the future, we need to witness more such type of things. Could you understand? This is what the concept. How can you understand the carrying capacity? By representation of the interrelationship between by representing the graphical representation between how the species are interrelated. This is what called as the concept of ecological pyramid. Is that clear? Okay. This is what the concept, the ecological pyramid. Now come to the, see, this is the introduction. This is what the theory, what that is there. What is the significance of the ecological pyramid? Just by looking at the ecological pyramid, you should be in a position to understand the health of the ecosystem. You should be in a position to understand what is the carrying capacity of the region. Okay? Don't go to the extremes like what happens next. We are not into that one. What happens next whenever the doomsday comes. Okay? We are not into that one. But my point is to instigate the doubt in your mind. Just to give that spark for the thought. You need to think in a different perspective. The more you think, the more the answer you will get. Right? Now, what is the ecological pyramid? Come on, come to the ecological pyramid. What is the ecological pyramid? Come on. The ecological pyramid is nothing but, is it clear? Is it visible? Is a graphical representation of the relationship between different organisms in an ecosystem. What is the ecological pyramid? It is nothing but the graphical, let me take red color, yes. It is the graphical representation. See this one, this is the graphical representation of the relationship between the different organisms in an ecosystem. This concept is given by a very great personality called as Charles Elton in the year 1927. Come on, write on. Same thing. Write on as it is. Okay. Very interesting questions. Okay. But sir, it is said that Earth has its capacity to heal itself. That's what the healing process. How the earth is trying to heal? By killing some of the people. Do you understand? The same concept is given by a very great personality called as Sir Malthus. Not Sir, Malthus. There was a great personality way back in the 1689 itself. He talked about the capacity of the earth, where his name is Malthus. He gave a theory called as Malthus theory, Malthusian theory. He said that Earth is having the capacity which is limited. Any addition of the population will create the diverse and the adverse consequences. Way back in the 1689 itself, he gave the concept. Reduce the population immediately. Okay, that is the concept of population in geography. That is a Malthusian theory in geography. Okay, let us not bring here. Now, understand this one. It is Mr. Charles Elton in the year 1927. He brought a concept called as ecological pyramid. What is ecological pyramid? Come on, write on. Give the side heading. Ecological pyramid. What are ecological pyramids? Ecological pyramid is a graphical representation of. This is there on the board. Come on. Is a graphical representation of relationship between different organisms in an ecosystem. Is a graphical representation of relationship between different organisms in an ecosystem. Then after this one, don't need to read all these things. Come on. Is a graphical representation of the relation between organisms in the different ecosystem. Full stop there. Given by Charles Elton in the year 1927. There are three types of pyramids. The ecological pyramids can be of three categories. The ecological pyramids can be of three categories. What are the three categories? The ecological pyramids can be of three categories. One is called as the pyramids of numbers, pyramid of biomass, second one. The third one is pyramid of energy. Side heading, pyramid of numbers. Give the side heading, pyramids of number. Listen. What do you mean by the pyramid of numbers? In any ecosystem, or in any area, maybe a national park, maybe a country, maybe the earth. If at all we are calculating how many number of species are located there, and if you keep the numbers in a form of a graph, then that graph will represent the numbers which are called as the pyramid of numbers. Like suppose I want to calculate the pyramid of number of maybe Jim Corbett National Park. Jim Corbett National Park. Where is this Jim Corbett National Park? It is there in the state of, where is Jim Corbett National Park? What is the importance of the Jim Corbett? The first national park of India. Which is the first national park of India? Where it is located? The first national park, Jim Corbett. Where it is located? Let me see the answer. Okay, now I want to calculate the Jim Corbett National Park. I want to calculate the pyramid of numbers in Jim Corbett National Park. Now what I will be doing as an ecologist, I will be counting how many trees are there. How many trees are there? Suppose there are 10 lakhs. Yes, it is there in Uttarakhand. Very good. Uttarakhand. Very good. UK. Very good. It's called as Uttarakhand, right? Now, within this one, how many deers are there? These are 10 lakhs. Maybe 1000 deers are there. Then 100 tigers are there. How I am representing? This is what the graphical representation. Graph which is based on the numbers. 10 lakhs over this 10 lakhs, 1000 over 1000, it is 100 tigers. It is what called as representing the representation of the number of species in a form of a graph. This is what called as the pyramid of numbers. This pyramid of numbers can be either upright or it can be inverted like this. The pyramid of numbers can be either upright or can be inverted. What do you mean by inverted pyramids? Now see this one. Whenever you are taking one ecosystem, may you take a ecosystem called as tree ecosystem. If you take a tree ecosystem, who is providing shelter for the birds? It is tree. Maybe just one tree. Tree is just one. Over the tree there are 100 birds are there. 100 birds are there. On the birds there may be some 10,000 parasites. Parasites are there. What are parasites? Parasites are those creatures which are feeding on the host. What is the host here? The bird is the host. How many parasites? More than the number of birds. Clear? Maybe on one bird you may be finding 10,000 1,000 or 2,000 parasites. Right? This is how the numbers. Whenever you are seeing the numbers within the ecosystem, you can take a tree as ecosystem or you can take the entire forest as ecosystem. Whenever you are calculating both, the pyramid can be either upright or it can be inverted. These are the two examples. Upright pyramid and the inverted pyramid. This is about the pyramid of numbers. The next one is called as the pyramid of biomass. What is the pyramid of biomass? What is biomass? Biomass is nothing but how much productivity a species is producing. Means what? How much the biomass it is producing. Like the best example, the more we eat, the more biomass we are having in our body. More biomass. What is the more biomass? Nothing but we can relate simply like this. It is said as the weight of the species. The weight of the species, how much organic matter is there in the body. The weight of the species is called as biomass, right? This biomass pyramid also either upright or it can be inverted. Means what? Whenever you are checking the weight of the species, means what? Take the case of this one. If at all you are weighing the weight of trees, all the trees, whenever you are weighing in one area, maybe you are taking one area like 1 square kilometer of area or just one tree. more the weight, which is having more weight, trees are having more weight. Then the next one, beyond the tree, who is depending upon the tree? Maybe a goat, maybe a what is called as deer, maybe the goats, maybe buffaloes. Group of within 1 square kilometer, how many trees are there? If at all you are weighing all the trees, more the weight will be there, therefore it forms the base. And you are taking the number of buffaloes that are located there. Maybe 1000 buffaloes are there in 1 square kilometer. And if at all you are weighing all the buffaloes, how much weight will be there? It will be the next one. This is the weight of maybe deers, maybe the buffaloes. And within that 1 square kilometer of area, how many lions are there? If at all you are weighing the lions, maybe 10 lions are there, not more than 10 lions. Therefore, the weight of the lions will be somewhat less. This is what? Upright pyramid for biomass. This very biomass pyramid can be even inverted. What is the best example? If you take a marine ecosystem, maybe the ocean, what is the basic food for the species in the marine area? It is the plankton. It is the plankton. What is the weight of the plankton? The weight of the plankton is very less. Therefore, it is plankton. This is the plankton that is there, right? This is the plankton. What the plankton, who will be depending? The fish is there. All the fishes will be there. Who will be consuming the fish? It is the shark. Who will be consuming the sharks? Even the whales. You can write one more level. Small fish will be consumed by the large fish. Large will by the shark. Sharks are being consumed by the whales. What is the weight of the whale? More weight. Weight of the shark, somewhat less. Weight of the fish, somewhat less. Weight of the plankton, further less. Therefore, pyramid of biomass can be even inverted. The last one, the pyramid of numbers, a pyramid of energy. The pyramid of energy can be only upright. There is no question of movement of the energy in a reverse fashion. What do you mean by the movement of the energy? Grass is consumed by the deer. Therefore, energy is transporting from the grass to the deer. Deer is consumed by the tiger. Therefore, energy of the tiger is being reaching to the energy of the deer is being reached to the tiger. There is no question of reversing. Like tiger cannot be consumed by the deer. Never the tiger can be consumed by the deer. Or never the deer can be consumed by the grass. There can be reverse flow of energy. Therefore, the energy pyramid is the one which is always upright like this. I will be uploading this one. You can check this one. Come and see this pyramid of numbers and the biomass diagrams are there. Yes, see the diagram. This is what the diagram. Pyramid of numbers. More producers. Next, herbivores less. Primary carnivores less. Further less. Further less. Then whenever it comes to the pyramid of inverted pyramid of number, tree, over this one you can find birds, over the birds you can find parasites, after these parasites you can find hyperparasites. These are the parasites you can find which is inverted. Then pyramid of biomass, see the weight of the biomass, trees less weight, more weight than that of the herbivore, than that of the carnivore, than that of the top carnivore. Then whenever you are talking about the inverted biomass, sharks, whales, more weight, large fish, less weight, small fish, further less than plankton, further less weight. Whereas the pyramid of energy all the time it is upright. This is about the energy or ecological pyramids. Is it clear? This is what the ecological pyramid concept. This is very, very important concept. What I will do, I will upload this concept. I will give to our class team. The class team will be uploading this one to your portal. Right? Is it clear? This is about the ecological pyramid. Give the next heading as ecological productivity. This we will be seeing in the next class. Okay, a question is there. Tushar and Rishabh has got the question. Please explain how the food wave phenomena works in omnivores like vegetarians and non-vegetarian humans. Why we consider non-vegetarian stronger than vegetarian if 10% rule is there? That question, whatever the Rishabh is talking about, is in a very narrow way. It is not like that. Don't take one particular section and talk about the what is called as transfer of energy, which is called as 10% rule, or the type of food chain that is happening, food web that is happening only in the omnivores. Only in the omnivores. No, it's not the omnivores alone which makes the food web. Food web is related to all the trophic levels. You cannot search food web in one trophic level. Within one trophic level, there is no food web. When the food chain can form, whenever the trophic levels are interconnected. What is omnivore? Only one level of trophic level. The question itself is quite narrow and it is a wrong question. Is it okay? Don't talk about the food web within the omnivores. No. What is a food web? Connecting different trophic levels. Right? Rishabh, go for the broader thinking. Don't see as an ecosystem as a whole. Don't say take one particular case and try to imbibe the rules that are given in the ecology. Right? Take the entire ecosystem, then talk about the food web and the connectivity. Then Tushar is having a question like, why 10% rule is not applied from plants to deers? Who said it is not applied? If deer is consuming one grass, why the deer will be keep on eating all the grass? Why deer can eat only one grass and can sit calm? Why the deer has to eat all the grass that is available in that area? Because one grass is giving 10%, another grass another 10%. It requires more energy. Therefore, it is taking the grass that is available. 10% rule is quite applicable at all the levels. Is it clear? Don't say that why it is not applied. Yes, it is applied. Is it clear? This is about the concept of food web, food concepts, food chain, then ecological pyramids, 10% law. Fine. The next concept is ecological productivity. This we will see in the next class. Until then, take care. See you. Bye bye.